Good morning, everyone. In the last class, we have discussed about the Watt's governor or pendulum governor and the limitations of the Watt's governor. Today, we are going to discuss about the or dead weight governor. The gravity loaded and dead weight governor are the Porter governor and Podley governor. The Porter governor is a modification of Watt's governor with central load attached to the sleeve as shown in the figure 1. The load moves up and down the central spindle. The additional downward force increases the speed of revolution required to enable the ball to rise to any predetermined level. The figure 1 is the systematic representation of the Porter governor. Then figure 2 is the line diagram of the Porter governor. The governor has the symmetricity with the spindle axis and the mass of the arm and link and spindle is negligible as compared to balls. The mass of the ball is small m and mass at the center on the spindle is capital M. The radius of rotation of governor is the horizontal distance from middle of the ball to the spindle axis, and height of governor is the vertical distance from middle of ball to the arm pivoted on the spindle. Omega is the angular speed of the balls. Fc the centrifugal force, T1 is the tension in the arm and T2 is the tension in the link, and the alpha is the angle of inclination of the arm to the vertical. This is the upper angle made between the arm and the spindle axis, and beta is the inclination of angle to the vertical. It is made between the link and the spindle axis, or the link is pivoted on a spindle. The method of resolution of forces. Here on the ball there are the four forces are acting: centrifugal force in the outward direction, weight of the ball in the downward direction, tension T1 in the arm, tension T2 in the link. So T1 cos alpha is equal to, first we resolve the vertical forces, then T1 cos alpha is equal to T2 cos beta plus omega. And here if you look at the point D, then T2 cos beta is equal to the half of center mass due to the symmetricity. So T2 cos beta is equal to capital M into gravitational acceleration divided by 2. So by substituting the value of the T2 cos beta in the equation, we get the equation number 1, that is T1 cos alpha is equal to capital M into G by 2 plus small m into G. Then resolving the forces horizontally, then T1 sine alpha plus T2 sine beta is equal to centrifugal force. By substituting the value of T2 in the equation 2, then we get the final equation, that is T1 sine alpha is equal to centrifugal force minus capital M into G by 2 into 10 beta. By dividing the equation 2 by equation 1, we get 10 alpha is equal to centrifugal force minus capital M into G by 2 into 10 alpha divided by capital M into G divided by 2 plus small m into G. And here 10 alpha is the radius of the porter governor divided by height of the porter governor, and the ratio of tan beta upon tan alpha, we assume it is a Q. Then substituting the value of tan alpha and the ratio of tan beta upon tan alpha into the, we will get the equation 3, and that is capital mg by 2 plus small mg is equal to centrifugal force, that is m omega square into r into h by r minus capital mg by 2 into q. So the height of the governor is h is equal to small m plus capital M by 2 into 1 plus q divided by small m into 895 divided by speed square. So in the central Watt's governor, we have height is equal to 895 divided by speed square, and this factor m plus capital M by 2 into 1 plus q divided by small m is the additional factor. This capital M is the center loaded mass to increase the limitation of the governor. When the length of the arm are equal to the length of the links, then the tan alpha is equal to tan beta, then q is equal to 1, then the height of the governor is m plus capital M divided by small m to 895 divided by speed square. If we consider the frictional force, the loaded sleeve moves up and down the spindle, then friction force acts on it in the direction opposite to that of the motion of the sleeve. Then the height of the governor S is equal to m small m plus capital M plus minus frictional force divided by 2 into 1 plus q divided by small m into 895 divided by speed square, represented by equation 5. And here plus sign is used when sleeve moves upwards or the governor speed increases, and the minus sign is used when the sleeve moves downwards or the governor speed decreases. Then we get the speed square. N1 square is equal to 17900. So N1 is equal to 133.8 revolution per minute. Similarly, for the maximum speed of the governor, when the radius of governor R2 is equal to 200 mm, then N2 will be maximum speed of the governor. Here S2 is equal to length of the arm square minus radius of the arm square. So S2 is equal to 0.15. So maximum speed of governor is given by N2 square is equal to 23867 rpm. So N2 is equal to 154.5 rpm. So range of the speed N2 minus N1 is 154.5 minus 133.8, that is 20.8 rpm. Thank you. In the next class we will discuss about the board leg governor.